High up in the Andes, enormous boulders the size of buses fit together with machine-like precision, no mortar, no gaps, and no explanation in sight. The ruins of ancient Peru are not just impressive, they are impossible. Scholars have measured, speculated, and wondered for centuries, but the complete truth has not been forthcoming. And now, thanks to modern advances in science and archaeology, new light is being shed, something much stranger, yet much more real, than anyone ever had the courage to dream. Buckle up. High on a pedestal of cloud-shrouded peaks, where the air is thin and the mountains stand like sleeping giants, there is a mystery etched into rock itself. Sacsayhuaman's walls over the old city of Cusco may appear to be remnants of an ancient past. Yet the nearer you get, the more bizarre they appear. Massive stone blocks, over 100 tons in weight, are wedged together with an exactness that appears to defy even contemporary engineering. No mortar. No visible seams. Just beautifully fitting stone work that has endured for centuries, unmoved through floods, invasions, and earthquakes that have leveled whole cities. Visit Ollantaytambo, and the mystery deepens. Almost 9,200 feet into the air, this temple fortress complex holds stones so enormous that even contemporary engineers acknowledge it would be a serious problem today to move them, even with cranes and heavy equipment. But somehow, these predecessors of ours quarried, cut, and transported them up the hill, over a difficult, uneven surface, without wheels, steel tools, or even an alphabet. The sight defies not only time but reason itself. And then there is Machu Picchu, the Inca gem so frequently lauded for being beautiful, but seldom for the simple impossibility of having been built. Placed upon a razor-sharp ridge subject to earthquakes and landslides, it is supported by an intricate network of terraces and drainage ditches that demonstrate not only sophisticated engineering but long-term environmental prescience. The stones here, as well, are so finely cut that even with a microscope, some of the joints are tighter than a human hair can fit through. At all these sites, again, a consistent pattern, sophisticated design principles, flawless workmanship, and megalithic stones transported and fitted with precision we generally expect of computer-guided machinery, not ancient people. What's more remarkable is the substance itself. These are not made from soft, easily curved stone. They were built with diorite and andesite, rocks that are so hard they are a notch below diamond on the Mohs scale. And yet, the craftsmen carved them into intricately curved shapes with sharp angles, curved smoothness, and joints that resemble those of molded stones. Bronze or copper implements, the hardest metals with which the region was familiar, shouldn't have been able to carve such stone at all. Present-day geologists have followed quarries several miles distant and attempted to replicate the method. But with today's cranes, trucks, and precision equipment, replicating the achievement is still nearly completely unexplained. Consider the quarries for Sacsayhuaman, several kilometers distant, separated by steep ravines and jagged inclines, with no evidence of flat transport roads. There is no record of wheels, draft animals capable of moving such loads, or the kind of advanced tools one would expect. Just stone placed against stone, aligned with uncanny perfection. Even more perplexing is the seismic resilience of these walls. Peru sits astride a tectonic fault, and earthquakes have repeatedly reduced its cities to rubble. Spanish colonial architecture, built with European-style masonry, collapsed in such earthquakes. But the megalithic Andean walls? They rode the shock, bending without collapsing, just as if they had been specifically designed to resist seismic shock. And the enigma is not limited to the best-known locations. Throughout the Andes, such as at Paisac, Taipan, and Moray, you see the same hallmark, exquisite masonry, high mountain sites, and unexplained shaping of stones. Each location, however isolated, has the unmistakable stamp of a mind, or a culture, that comprehended materials, landscape, and time on a scale far greater than conventional history provides for. These are not creations of primitive hut dwellers or even pyramid builders. They are something else altogether, an architectural signature that implies either forgotten wisdom or an intelligence incomparably more sophisticated than we now recognize. Which raises the question, how did these buildings get carved, transported, and put together with such impossible accuracy, without the tools, techniques, or technology we possess now. Stand in front of the Cyclopean walls at Sacsayhuaman or the Sun Temple at Ollantaytambo and one question overshadows all others: how? Not, how amazing, but literally, how was this done? The textbooks provide no definitive response. What we do have is irrefutable physical evidence: stone mass, weight, geometry, that does not coincide with the abilities we assign to the ancient world. First, sheer size. At many of the highland sites, some stones are between 50 and 120 tons in weight, with a few over 200 tons. They were not constructed in situ from local stone. They were brought from remote quarries, over rough mountain tracks, across streams, and up steep inclines. There is no evidence of wheels, and no animal familiar to the area could have pulled such weight. No evidence of large-scale sled hauling infrastructure has been discovered. And upon arriving at the site, the stones were not merely piled. Each one was cut to fit like a specialized puzzle piece, sometimes into places where they locked into as many as 12 others. Each joint is solid, each fit precise. And though there is no mortar, these walls have stood for centuries, through huge earthquakes that devastated later Spanish constructions to rubble. The stones seem to bend and compact without buckling, as if nearly engineered with knowledge of seismic forces. This type of construction, polygonal masonry, is found almost nowhere else on Earth, and current engineers concede that to duplicate it now would be an expensive and laborious process, even with modern machinery and CAD programs. The tools available to the Incas, or any culture before them, are another sticking point. With only bronze and copper implements, carving diorite or andesite should have been impossible. To modern builders, it's like trying to sculpt glass with a wooden spoon. Geologists confirm that shaping these stones requires tools of equal or greater hardness. Yet no such tools, forges, or manufacturing debris have ever been found. Some have long, smooth cuts like they were cut with modern saws. Others have flat faces and sharp, machined corners. In others, the stones appear to have been softened or molded. The renowned stone of 12 angles in Cusco fits into its position with a complexity that implies it was fashioned when the rock was soft. But no chemical or natural process known can have softened such hard stone without extreme heat or industrial processes, none of which were available in recorded ancient Peru. Other researchers have hypothesized lost methods that might have changed the molecular composition of the rock, perhaps by heat, acoustics, or plant chemicals. Amazonian legend even describes a plant that can soften stone, although no scientific evidence has been found. And then, of course, there are the machine-like impressions, drill-like punctures, scooped-out recesses, and smooth scoop-outs the size of a human body, uniform, symmetrical, and nothing like the rough hammer strikes to be anticipated with primitive tools. These buildings were not just strong, they were smartly functional. Drainage corridors, slope profiles, and water networks are incorporated into the stonework. Farm terraces were constructed to control rainwater and avoid erosion. Machu Picchu's watercourses work flawlessly today. These elements involve profound understanding of geology, hydrology, and environmental design. Others suggest this may be attributed to pure manpower and brains over generations. But the chronology doesn't hold. The Inca Empire that arose in the 13th century didn't have centuries to burn. And importantly, they never said they constructed the megaliths to begin with. Their oral traditions respectfully indicate these buildings were passed down from previous builders. The evidence leads us to this fact: these walls were not created through guesswork or sheer strength. They were specifically designed using skill and knowledge that equals, and in some areas may even exceed, our own. Which brings us to the next question: if the accepted tools and time frames don't match, what does modern science really have to say? The one piece of evidence perhaps most revealing about history is the most straightforward: the Inca themselves told them they did not construct these megaliths. When the Spanish conquistadors came in the 1500s and inquired as to how such stonework was done, the Inca responded simply, "These walls already existed." The Inca were formidable builders in their own right, developing advanced terraces, roads, and temples. But their construction, although impressive, is clearly different from the larger, older, more accurate stone blocks used in the foundation of most sites. Frequently, their own masonry sits directly upon or next to these older buildings, with an obvious chronology: what was first was stronger, more accurate, and more technologically advanced. It is difficult to date these megaliths. Stone cannot be carbon dated, so archaeologists must use organic material contained within or near the structure. In most instances, subsurface samples from deep foundation layers have returned dates thousands of years prior to the Inca Empire, indicative of sophisticated human presence in the Andes as long ago as 4,000 or 5,000 years, quite possibly longer. Geological research has revealed that most of the stones at Ollantaytambo originated from a quarry on the opposite side of a river and up a steep incline, kilometers away. With modern techniques, it would be very hard to move such huge blocks under such circumstances. No trace remains of the enormous ramps or road systems the old transport systems would demand. Microscopic examination has shown surfaces so polished they look like they have been done with industrial equipment, as well as grooves and cuts indicative of high-speed rotary equipment. In 2022, a peer-reviewed geoscience paper discovered that some stone grooves could not have been produced by chiseling alone, officially leaving the method unexplained. Technological progress in satellite photography and LiDAR scanning has shown that it is merely half the story of what we observe above ground. Underground are geometric patterns, subterranean terraces, underground rooms, and even submerged aqueducts. At Sacsayhuaman, subterranean tunnels and voids, possibly artificial caverns, were found by LiDAR and left unexcavated. Astronomical alignments introduce another level of sophistication. Locations such as Machu Picchu and the Coricancha Temple in Cusco are aligned with solstices, equinoxes, and other astronomical events to a remarkable degree. The megalithic base of the Coricancha is aligned with the sunrise of the June solstice to within a fraction of a degree, implying sophisticated astronomical observation and mathematical calculation. In 2024, a roundtable at the University of San Marcos in Lima assembled archaeologists, geologists, and engineers. Some admitted freely that parts of these structures cannot be accounted for by existing historical paradigms. They were not fringe theorists but mainstream academics, willing to take the evidence where it may go. The greatest enigma perhaps is not who constructed these megaliths, but how. If the tools we think they possessed at that time were not up to the challenge, if the Inca were not the initial constructors, and if the chronologies don't match, then what sort of civilization possessed the ability to do this?